Hi everyone, in this examples we will take some more proofs using intermediate value theorem, and we have two parts, A and B. In part A, suppose that f is continuous on the interval 0, 1, that f of 0 equals 2, and that f has no zeros on the interval. Prove that f of x is greater than 0 for all x in the interval from 0 to 1. Now, as you see, the function is given, but we don't have any rule for the function f of x. We have the condition that f is continuous, which means the first condition in the I.V.T is satisfied for the given function because f is continuous from the question, and you have to prove that f of x greater than 0. Here you have to use the proof of contradiction. So you want to prove that f of x is greater than 0. Suppose not. This is the first step. Suppose not. Suppose not means we have two cases. Because you want to prove that f of x is greater than 0. Okay, the converse of this statement is two statements. The first one is f of x equals 0, and the second one f of x is less than 0. So the first statement, suppose not, means maybe the function f of x, this is case 1, maybe f of x equals 0, which is incorrect. This is a contradiction because f has no zeros in the interval. So this is not true. So f of x equals 0 is not true. Now the second case is f of x less than 0, negative, for some x and the interval from 0 to 1. Okay, so let's say that we have a number inside the interval from 0 to 1. So let's say that we have c and the interval from 0 to 1 such that f of c is negative, less than 0. So as you see, this is our interval. This is 0 and this is 1, and we have c here such that f of c is negative, less than 0. From the question, f of 0 equals 2, and 2 is a positive number. So here the function f is continuous in this subinterval from 0 to 1. F is continuous, and f of 0 and f of c have opposite signs, which means in the interval from 0 to c, which is subinterval from the interval from 0 to 1. And this means again that we have some number between 0 and c. Let's say a, we have a between 0 and c such that f of a equal to 0. But this is not true. This is not true because we don't have any zeros in the interval from 0 to 1. So the second case is not true. So firstly, we suppose not, and we have the two cases equal 0 and less than 0, and this leads to contradictions in both cases. And this means that f of x must be positive and the interval from 0 to 1. And this is the end of this question. It's a proof by contradiction. Now in part B, use the intermediate value theorem to show that equation e to the x plus 2 cosine x has exactly one positive root. So you have to use the intermediate value theorem to show that e to the x equals 2 cosine x has at least one positive root. But you know that if you want to use the intermediate value theorem, you have to get a function and an interval. But here we don't have an interval, so here you have to create a function and create an interval. So firstly, since you want to prove that this function has a root or a positive root, positive root means you have to take interval greater than 0. Okay, so the function will be f of x equals e to the x minus 2 cosine x. Okay, and by trial and error you have to check this interval from 0 to pi over 2. The interval must be, all the values of the interval inside must be greater than 0, since you have to prove that we have one positive root. So let's see this interval, and we want to check if it's true or not for the given function. For the first condition and the I.V.T is the continuity, and as you see, since e of x is continuous everywhere and 2 cosine x is continuous everywhere, this means f of x is continuous because it's a difference between two continuous functions. So f of x is continuous on the closed interval from 0 to pi over 2. So the first condition satisfied. For the second condition, you have to evaluate f of the endpoints. The first one f of 0 and the second one f of pi over 2. Now f of 0 is e to the 0 minus 2 cosine 0. Now e to the 0 is 1 minus cosine 0 is 1 multiplied by 2 equals 2, and you will get negative 1, which means it is negative, less than 0. Now you have to check what about f of the second endpoint, which is f of pi over 2, and this gives us e to the pi over 2 minus 2 cosine pi over 2. Now cosine pi over 2 is 0, so we have e to the pi over 2, and this quantity is greater than 0, which means it is positive. So our interval is true because the image of the endpoints under the function f have opposite signs, which means the second condition and the I.V.T is satisfied for the given f. Now what is the conclusion? What is the conclusion? The conclusion is there is at least Cn, the interval from 0 to pi over 2, such that f of c equal to 0, but f of c is e to the c minus 2 cosine c equal to 0, and by moving 2 cosine c to the right hand side you will get e to the c equals to cosine c. And since c in this interval, this means the root is positive, and this is the end of this question, and that's it. Thank you very much. Don't forget this square.